Hello, my name is Anand Iyengar. I'm one of the founders and CTO here at CloudVelox. Today we're going to see our One Hybrid Cloud platform software that lets you take your existing physical or virtual systems into cloud environments like Amazon or Azure. This lets you leverage the agility, protection, and efficiency of these cloud computing systems for your applications. So let's go dive in and take a look at the system. So for this demonstration, what we're going to do is look at a multi-system, multi-tier application that we've configured. The systems themselves happen to be running in Rackspace. And they're running an application called Sugar CRM. First, I'll log into that. And we'll go to the accounts page. And we can see that the system itself has been configured with some initial data with a number of accounts. So now I'll go to the CloudVelox login page and log into the CloudVelox portal. The initial dashboard gives you an overview of the systems. You can see that all 4 systems that are running the application are connected. This is the bandwidth that's being used between the local systems and the cloud. And you can see that the bandwidth requirements are pretty low on an ongoing basis. And this is recent activity that's happened on the accounts themselves. So if I go to the cloning page, on the cloning page we can see that we have a couple of applications configured. We'll take a look at the Sugar CRM application that we're logging into and demonstrating. We can see that there are 4 servers, a load balancer, a pair of web servers, and a database server. We have some information about these systems: the operating system version, relative performance of the CPUs, some amount of memory, storage volumes and mount points and sizes, the network interfaces and IP addresses, and a rough cost of running these systems in the cloud. So all this is extracted automatically from the systems. There aren't any forms that you have to fill out or anything like that. There's a drag and drop interface which lets you configure these systems for bring up in the cloud. Okay. We also have some more information about the systems themselves. When we click on them, we can see their current running stats and some other information about the systems. The network bandwidth used, the CPU load, the amount of memory that's available, and the packet transfer rate. So I'll go back to the cloning page. And what I'll do is I'll go through the process of creating a new application so we can see what steps are involved in bringing a multi-system application into the cloud. So first we press the Add New Application button. So what we get is actually a configuration palette and the machines on which we've installed the software. It's very easy to configure the systems for the cloud by just taking the machines here and putting them in the appropriate box on the right. The systems in the public area are accessible from the internet directly. The systems on the left-hand side in the private area are kept sequestered from the internet, but can talk to the systems in the public area and each other. So in this way, we can specify only the systems that we want publicly accessible. So for example, here, we'll put the load balancer in the public side. We'll put these web servers in the private side. Oops. And the database server also in the private side. And we'll give the application a name. Oops. New app. And we'll save that. And for database servers, we automatically tie in with certain databases such as MySQL, and we extract from the servers the configuration necessary to synchronize them into the cloud without any extra work. So in the case of MySQL, we'll automatically parse the my.cnf, figure out where what the paths are for the database, and automatically configure in some recommended configurations. You don't need to use our configuration. You can override any of this or invoke your own custom scripts if you'd rather do that. If for some reason you have some type of database that can't be synchronized live, you can quiesce it, or you can choose not to do anything. In this case, we'll take the defaults that the system has provided, since they're pretty good. We'll press Next. And here we see a configuration screen for the different file systems in the group of machines. So what this lets you do is decide which parts of the systems you'd like to take into the cloud and which parts you'd like to leave in your own data center and not copy into the cloud. So in this case, the defaults are pretty good. So we'll press Save and Continue. And what we get is a verification screen, just so you can make sure that everything looks OK. So in this case, the defaults look pretty good. So we would just press Protect. This would take us back to the configuration screen and add a line to this table for the new application. In this case, since we've already configured it, we'll use our existing application for the demonstration. So normally, the initial status for an application is synchronizing. In the case of these 4 machines, that takes about half an hour. And after that time, after the machines have been synchronized into the cloud, we press the clone button and we can start up a copy of the systems in the cloud. So I'll press clone now. We'll create a new group of machines. We'll make this Anand Sandbox number 1. And the defaults here are pretty good, so we'll just launch that group of machines. What's happening now is CloudVelox is configuring the back-end systems in the cloud. So initially, we create an Amazon VPC, that is a container for the systems in the cloud. Within that, we create multiple subnets. And these systems happen to have a single subnet, but if they had 3 or 4, we'd create all of those and tie them together with routing and any other components necessary for those systems. And then we would launch the systems themselves in the cloud. So this involves generating images of the machines, attaching storage volumes to instances, bringing up and launching those instances within these networks and assigning them IP addresses, and then having the operating system itself boot up. So we'll see that process happen here over the next few seconds. So now we can see we've launched systems in the cloud. We've gotten the networking and everything else up and going. I'm just going to close this and go back to the main page here and refresh our status. It'll take just a few minutes for these systems to boot in the cloud. The machine operating systems need to come up and start running along with all the applications and services on those systems. Let's take a look at the machines within the sandbox itself now. So what we see is we have the same 4-system configuration that we saw initially. We have a load balancer, a pair of web servers, and the database server. But we can see that these systems underneath their host names have an Amazon instance ID. So here underneath the Sugar 3-LB node, we can see this number which starts with I-56A. That's actually the Amazon instance ID, showing that these systems are actually running within Amazon itself. Down at the bottom, we see similar information to what we had seen in the application configuration, the host names, operating systems, CPU and RAM configuration from before. One thing about CloudVelox is that it takes over everything about the systems. That is, it will copy not only the application and application data, but also the system libraries, system executables, even the modules and underlying OS kernel itself. So in this way, when these systems get launched in the cloud, they have a copy of everything, including the OS kernel and whatever's necessary to make the application itself run. So all the dependencies are covered. What we do is we don't actually conform the systems to Amazon's offered kernels. We actually generate our own custom AMIs based on the kernel that comes from the data center itself. These applications are running, in this case, within rack space. So on the right-hand side, you can see that that the systems have an internal IP address, which is the same as the original IP address they had in rack space. So this is very important because these systems themselves can talk over the same IP addresses they used within rack space originally, so that even if the application were badly written and it had hard-coded in the application or in a database or something like that, the IP address of the constituent systems of the application, it would still come up and run because we preserve those IP addresses and convert them to internal IP addresses within the Amazon VPC in this case. So they're still available and usable for connections and routing and everything else. In order to access these running systems in AWS, we connect to the external IP address that's shown here. So here I'm going to copy this Amazon EIP, create a new tab, paste it in, add Sugar CRM to it, and hit return. What we see here is the login page for the application. And I'll just log into this. And so this copy of the application is running independently from the original. And what we can do is when we get to the application page itself, we can click on Accounts. And we can see that the accounts that are in the copy are exactly the same as the accounts that are in the original. You can see the original system's IP address, and here's the copy. So when we go back and forth between the two, we can see that they're exactly the same. One nice thing about CloudVelox is you don't have to stop at just one copy of the application in the cloud. In the same way that we created this first copy of the application, this initial sandbox, we can create a second copy also. Okay? Here I'm going to click on the clone button again, and we're going to make this our dev test sandbox number 2. We'll launch this. And in the same way that the initial sandbox was created, the second sandbox will also be created within AWS, and the systems will be launched in isolation from the original systems. This will take just a minute to finish. Now we've had the second clone is launched. We'll just go and click on that and see some detail about this. We can see that we also have 4 systems here, and they've also been launched within their own VPC. The instance ID here is different than our originals, and also the external IP on which the load balancer offers service here is also different from the first clone that we made. You can see the EIPs are preserved again here, but since they're contained within the Amazon VPC, they're accessible only by these systems. So in this case, these machines can also internally refer to each other by the IPs they originally used in the data center in Rackspace. One important component about CloudVelocity is its ability to extend the services from the data center into the cloud. So these systems can request DNS service from the DNS in the data center itself. And also, if they had any other services they depended upon, like, for example, LDAP, those services would be available in the cloud as well, even though the LDAP server may not be authorized to be taken into the cloud. In this case, custom tunnels are automatically generated from the data center into the cloud for those services. You can also customize those tunnels as well. So if you have a particular database or some other type of application where you need to send the request back to the data center, these tunnels and connections can be generated automatically for you. So what I'll do now is I'll take the external IP address of this other load balancer. I'll copy this, paste it into a new tab, add Sugar CRM to it, and hit return. OK, so now the copy is up and running. We'll log into this copy as well. And in the same way, we'll go to the accounts page. And we can see that it also has a copy of all the data from the original system as well. So the second copy, original. First copy, original. All these systems are running simultaneously within Amazon. So we'll go back to our main cloning screen here. And what we've seen is we've been able to bring up multiple copies of the application within AWS. What I'll do now is I'll go through some of the other use cases of CloudVelocity and show you some of the other features we have available as well. So now I'll go to the download screen. Here we can see different versions of the software that are available for Linux. In this case, you can download the software and install it yourself, or have us go through a discovery process where we find your systems and install the software for you and automatically configure it for you as well. When you download and install the software, there's no additional steps you have to go through. We automatically set up your system for use of CloudVelocity service and set it up to connect to the right portal in the cloud automatically. We also have a separate screen for migration. Here you can set up migrations of your software into the cloud the same way that we launched the clones in the cloud. We try to make the user interface consistent with that so that there's not any additional learning or other steps you have to go through. You just press the migrate button, pick a name for it, Sugar in the Cloud, and launch. And in the same way we saw the systems being launched in the cloning page, we can see the systems being launched in migration as well. Rather than wait for this to complete, we'll just close it so it happens in background. And we'll go to the failover page. And here you can see that we've also kept the UI the same as with the cloning and migration, so that if there were any kind of outage in your local data center, whether it's systems or connectivity or infrastructure or power, you can press the failover button, and in the same way that you just saw, within 10 minutes have a group of machines up and running your application without a lot of effort on your part, and without having to have extensive knowledge of the cloud or your application to make this happen. OK, let's go back to the cloning page, and we can take a look at our systems which are up and running in the cloud. We've seen how to launch machines in the cloud, bring them up very easily, configure our applications for the cloud with the drag and drop interface. Let's also show you a couple of other features of CloudVelocity. You can also pause systems that are up and running, so we can press suspend here to take the state of the systems as they are and preserve them to persistent storage. In this case, within Amazon, these systems are stopped. AMIs are automatically generated, The systems themselves are stored away so that you can resume them at later points whenever you'd like. In the same way, we can also stop a group of running systems by pressing the stop button to terminate them and have them shut down. Okay, so now that we've gone through this demonstration, let's just kind of talk about all the steps we've covered for this production set of systems that have been brought into the cloud. We've gone through the process of discovering the hosts that are part of the service, blueprinting them to figure out their configuration and their setup, provisioning the necessary resources in the cloud to receive this information, synchronizing the state of these systems into the cloud, and finally, through the cloning process, initiating service for these systems in the cloud and actually trying out the running machines so we can see what they'd be like in the case of an outage or in the case of migration of these systems into the cloud. So to summarize, we have a very simple automated process for taking your production systems, your multi-system, multi-tier applications from your local data center into the cloud, and also extending any services that they need from your data center to the cloud as well, so that you can benefit from the economics, the agility, and the protection offered by cloud systems such as Amazon and Azure. As you can see, we've deployed an application into the cloud in such a way that it can be used to support production use cases such as disaster recovery and dev test. If you have any questions, please go to www.cloudvelox.com. Thank you.